class 9. Today we'll start a new chapter, that is chapter 3, laws of motion, and in that we'll start with force. A force is that physical cause which changes or tends to change either the size or the shape or the state of rest or motion of a body. So on the basis of applications, there are two types of force: contact force and non-contact force. Now we'll start with contact force. The force which are applied on the bodies by making a physical contact is called contact force. There are several contact force, that means two bodies which is applying the force and on which we are applying the force, both should be in direct contact with each other. We'll start with frictional force. When a body slides over a rough surface, the force starts acting on the body in the direction opposite to the motion of the body along the surface is in contact. So this is called frictional force or the force of friction. Always frictional force is in the opposite direction of the applied force. Suppose, as you can see, this cycle is moving in a direction. So the direction of the motion of the cycle indicates the green arrow, but red color of the arrow which is indicating the frictional force, just opposite to the direction of the applied force. Next, we will start the next force, that is normal reaction force. So when a body is placed on the surface, the body exerts a force downwards equal to its weight on the surface, but the body does not move because the surface exerts an equal and opposite force on the body normal to the surface, which is called normal reaction force. So as you can see, this box is kept on the table and there is a normal reaction force acting on that. Fw is the weight of the box and Fn is the normal reaction force. Now moving on to the next force, that is tension force applied through a strings. When a body is suspended by a string stretched to a rigid support, the body, due to its weight W, pulls the string vertically downward, and the string in its stretch condition pulls the body upward by the force which balances the weight of the body. So this force developed in the string is called tension force. It is denoted as capital T. As you can see, there is a pulley which is with which the string is just suspended. Now moving on to the next force, that is force exerted by a spring. Consider a spring which with its one end kept fixed. If its other end is either stretched or compressed, the spring exerts a force opposite to the direction of the displacement of its free end. The magnitude of this force is directly proportional to the magnitude of displacement. That is, either it elongates when is there, either compression is there. This force is called restoring force. So the spring, when it is fixed at one end, there is a force, that is restoring force occurs, which is opposite to the direction of the applied force. Now moving on to the next, when two bodies collide, they push each other. As a result, equal and opposite force act on each body. These forces are called the force of action and the force of reaction. So there is a force of action and a force of reaction. The reaction force occurs when two bodies collide with each other. Now the next topic, that is non-contact force. So the force experienced by the body when bodies, even without being physically touched, are called non-contact force or the force at a distance. So these bodies are not in direct contact with each other, they are not touching each other, still a force exerts, that is a non-contact force. There are three types of non-contact force: magnetic force, electrostatic force and gravitational force. We will start with the first, that is magnetic force. Two like magnetic poles repel each other while two unlike magnetic poles attract each other. The force between magnetic poles is called magnetic force. So here you can see when A pole of a magnet is brought near the iron nail. An opposite polarity is induced on the nail and it moves towards the magnet. The motion of the nail is due to the magnetic force of attraction exerted between the unlike poles and the magnet and the nail. Moving on to the next, electrostatic force. Two like charges repel while two unlike charges attract each other. The force between the charges is called electrostatic force. Here we have an example with a comb. When a comb is rubbed on dry hairs, it gets charged. If this comb is brought near the small bits of paper, opposite charge is induced on the bits of paper and they begin to move towards the comb. They are not really touching each other, but still the paper attracts towards the comb because of the opposite polarity of charge developed on the comb and the paper. Moving on to the next example, that is gravitational force. Force with which Earth pulls everything towards itself is a gravitational force. It is the force of attraction between the particles of matter. Suppose, for example, a ball thrown up returns back to the earth due to the gravitational force. So, general characteristics of the non-contact force, that is, the gravitational force is always attractive in nature. Very first and most important question of this topic is the characteristics of non-contact force, and it has 2 points. Number one, that is, the gravitational force is always attractive in nature, while electrostatic force and magnetic force can be either attractive or repulsive according to the polarity between the two bodies. Now moving to the second point, the magnitude of non-contact force on the two bodies depends on the distance of separation between them. It decreases with the increase in separation and increases as the separation decreases, because it inversely proportional to the square of the distance between the separation. Force is inversely proportional to the square of the distance between the separation. Now the one numerical is there of the last exercise, that is exercise 2C. Numerical number 15. A train starts from rest and accelerates uniformly at the rate of 2 meter per second square for 10 seconds. It then maintains a constant speed of 200 seconds. Here the speed is constant. Then brakes are applied and then train is uniformly retarded and comes to rest in 50 seconds. 3 variation of time. First it starts 10 seconds, constant 200 seconds, and it for rest again 50 seconds. We have to first calculate the maximum velocity reached. For that, first write the givens. Vu is equal to 0, acceleration 2 meter per second square, time is given 10 seconds. Using the first equation of motion, V is equal to u plus at. Substitute the values, we'll get the answer as V is equal to 20 meter per second. For the next one, we are calculating retardation. Acceleration we have to calculate. For the displacement, substitute again in the first equation of motion and you will get your retardation as 0.4 meter per second square. Here is an error of, just do it, minus 0.4 meter per second square, it is 2. Now to calculate the second part, that is total displacement, we have to add the 3 distance traveled by the in first 10 seconds, distance travel in 200 seconds, and then distance travel in last 50 seconds. Then we can get the total displacement. For the first 10 seconds, using the second equation of motion, that is S is equal to ut plus half at square. When you substitute the value, u is 0 because it start initially at rest. Substitute a is equal to 2 and we'll get the S1 as 100 meter. For the second distance, since it travels uniform distance, so for 200 seconds, that is simply we'll calculate distance is equal to speed into time, and 4000 meter. The second S2 is. Now moving on to the next one, the distance travel in last 50 seconds, again it stops in last 50 seconds. So using the second equation of motion, S is equal to ut plus half at square, substitute the value of u, t and a, we can simplify and get the value of displacement, that is S3 is equal to 500 meter. Now add the total S1 plus S2 plus S3, make it S1, here is an error, S1 plus S2 plus S3. So total displacement is 100 meter plus 4000 meter plus 500, that is 4600 meter. Now the last part of the numerical, they are asking the average velocity, which is equal to total distance travelled by total time taken. Total distance, just now we calculated 4600 meter, and total time taken, first 10 seconds, then 200 seconds, and then 50 seconds. Then when you will add this, you are getting the total time as 2660 seconds. So when we simplify, we will get the answer as 17.69 meter per second, the average velocity. Like this, practice numericals. Thank you.